Good morning and welcome back. I'm going to run through the velocity of the potato. So if you recall, we had a potato inside of a potato launcher, and I'll just give you the rundown of what that looked like. So we had basically the chamber and the barrel. Okay. And hopefully you can see that. It's a little bit clear. I'm also trying to record directly to YouTube, so it's not going to be to the video. So hopefully this comes out a little bit clearer. We'll see. So what we had the valve over here, and a potato sitting pretty over here, waiting to be launched. And this was pressurized. And what we also knew was the given requirements were pressure was 16 psi. The mass of the potato was 500 grams. The length of the barrel is 2 meters. And the diameter of the barrel was 2 inches. And this is specific to the actual potato gun we have in the classroom. And hopefully you can see that. All right. So basically, just going to run you through as to what happens here. Well, according to Pascal's principle, the pressure that's inside this chamber that was measured on the little pressure gauge over there, which gave us 16 psi, that pressure is the same throughout the entire chamber, meaning that that pressure is the same up here as well. So pressure, as we know, is equal to force over area, which would mean that force is equal to pressure times area. So the area that we're looking at here is the circle or cross-sectional area that is pushing on the potato. So what's going to happen here is we have a force that's going to push on the potato over a distance of L, being the 2 meters. And if I have force over the distance, that's going to be work. So basically what I have is force times the force times the distance L will be equal to the work, which is going to be in turn equal to the change in kinetic energy. And if the kinetic energy at the beginning is 0, then that will be equal to the kinetic energy final. So what I'm looking at here is the force, which was the pressure times the area, times the distance, is equal to the final kinetic energy, which would be 1/2 mv squared. And V is what we're looking for. V is all you need, right? So that's what we're looking for. So if I get V by itself, I'll see that I have 2 best buds. You get it? 2 pals. I multiply a 2 on both sides. And I'll divide by the mass. I'll take the square root to get the velocity. So this is everything in terms of the variables. But let's get some numbers to this so we can see just what they require. So this would be the case. I can just plug and chug if I had everything in the correct units, which I do not. So I have 16 psi, so I have 16 pounds per square inch. So if I convert that correctly, I'll take 16 pounds. I want to put that into Pascal, which is going to be newtons per square meter. If I take 16 pounds, 5 is equal to 71.2 newtons.
Critical blood drives throughout the country at a time when blood shortages are widespread. Click the ad to learn more.
And I have square inches. So I know that 1 square inch, I'll just substitute that down here. 1 inch is going to be 0.0254 meters, and that would be squared. So the pressure then would be 71.2 divided by 0.0254 squared and I get a very big pressure of 110,360 pascaloons. Okay, so there's my pressure. That's in the appropriate units. The area, however, I do not have the area, so let's do that one. My diameter is 2 inches, so the radius would be 1 inch, and the area of a circle would be pi r squared. And I'm just going to substitute now for r, the radius of 1 inch.
That's why we're open for pro business hours 6 to 7 a.m. Monday through Saturday. You'll find the quantities you expect with dedicated pros.
And I square that to give me my area.
Now more than ever.
Plug along.
Every single bit.
Pi times 0.0254 squared, and I get 0.002027, we'll say. And that would be in square meters. Now look at that. This thing is only 2 inches wide. I'm nowhere close to a square meter, so therefore, yes, that is going to be making sense. All right. So there's my area. And pressure's taken care of, area's taken care of, length. My length is in meters already, I don't have to do anything there. Mass, 500 grams. Well, that's going to be 0.5 kilograms, so everything's in the appropriate units. So now it's just plug and chug time. I take this bad boy here. I plug in the right variables to get that. And let's see if we can verify that we got the same thing. 2 times the pressure, 110, 360, times the area, which I just got, times the length of the barrel, divided by half a kilo. I take the square root, and I've got a velocity 42.3 meters per second. That's pretty fast. That's extremely fast. But there you have it. So that is the answer to the velocity, and we are all good to go. All right. Hopefully I'll see you tomorrow or Wednesday in our showdown. Bring your A game.